let's look at the explicit and recursive forms for arithmetic sequences using an example. Let A10 equal to 2. That means the 10th term of an arithmetic sequence is 2. And the common difference, let's say it's 5. So the explicit form is basically an is equal to a1 plus d times n minus 1. Let's see what we have. We already know d is 5. We need to find a1. So we can use this information right here. We know that a10 is going to be equal to a1 plus d, which is 5, times 10 minus 1, which is equal to 2. N is equal to 10. That's what I have right there. And I know a of 10 is given to us as 2. So we can solve a1 plus 5 times 9, that's 45, is equal to 2. Now we have the two pieces of information that I want, a1 and d. Once again, let me write the general form that I want to use. A of n is equal to a1 plus d n minus 1. So an is equal to a1, which is negative 41, plus d, which as we know is 5n minus 1. I can stop here, but it's always a good idea to move forward and simplify this. So I will distribute the 5. I will end up with an is equal to negative 41 plus 5n minus 5. And then I will combine like terms. I will end up with, and that is my explicit form of the arithmetic sequence. From this form now, we can go ahead and find a few terms. We can find, let's say, a2. a2 will be, I just have to replace 2 into my equation. So that will end up being negative 36. We have already established that a1 is equal to negative 41. We need that. The recursive form will be this. an plus 1 is equal to an plus d. The next term, that's what n plus 1 means, is equal to the current term plus the common difference, which makes sense. Every time when you add d to whatever you have, you end up with the next term. However, you cannot use the recursive formula unless you have also a1. a1 has to be given to you. A of n plus 1 is equal to an plus 5. And then I will also give you a1 is equal to negative 41. This is my final answer here. And this is the recursive form. For the recursive form, you need to have a1. a1 has to be given to you. So for example now, what is a2? Well, a2 is a1 plus d. And a1 is of course given to us. We already found it previously, which is here. So a2 is a1 negative 41 plus d, which is 5, and that will give us negative 36. What is a3? Well, I can't find a3 unless I have a2. And then a3 is a2 plus d. a2 has already been calculated. So I will end up having a3 equal to negative 36 plus 5, which is negative 31. And then from here, you often want to distribute the d so that it looks more simplified. Whereas the recursive form is a1 must be given to you. Sometimes you will see the recursive form written like this. So all that it means is to know the current term, you have to know the term that came before it, then you add d. Now, if I want to find, let's say, a of 10, I can simply take 10, put it here into the explicit form, I will get the answer right away. But if I want to find a of 10 using the recursive form, first I need to know a of 9. And I can't know a of 9 unless I have a of 8. And I can't know a of 8 unless I have a of 7. And so forth until I get to a of 1. So a of 1 must always be given. That would be a of n is equal to a1, which is 3, plus d, where I can see that the common difference is negative 1 times n minus 1. Now let's simplify that. Whereas for the recursive, I will say a of n is equal to a of n minus 1 plus d, well, in this case d is negative 1, so I will do minus 1, and then a1 is equal to 3. This is the form. Okay.